Well, first of all, happy vacation. This is your first lesson of vacation. Now, before you get all grumpy with me on this, all the past years I've given him just copies of my notes, and you guys had to copy down the notes without any instruction that followed it. So this is way better than prior years, and it's the only way to keep us on track with the AP schedule the way it is, okay? So hang in there, you guys. This is not a hard lesson right here. So here's board problem 35. Which of the following pairs of events are disjoint, mutually exclusive? Remember, disjoint are two circles that do not overlap, so there's nothing in common with them. So A, the odd numbers, and B, the number 5. Well, no, it's not that one because 5 is odd. B, A, the even numbers, and B, the numbers greater than 10. Well, that's not either because there's numbers greater than 10 that are even. Okay, C, the numbers less than 5. And then B, all negative numbers. Well, no, all negative numbers less than 5. It's not that one. D, the numbers above 100, and that's A. And then B, the numbers less than negative 200. It's that one. They don't share anything in common. So um, uh, it's that one. Okay, and negative numbers, there are odd negative numbers, so it's not E. There's choice D. Alrighty? Here we go. Okay, so this is called discrete and continuous random variables. This is section 7.11. And discrete random variable is a random variable x such that these characteristics occur, you guys. The value of x, it doesn't matter how many x's you have right here. Whatever these values are, I can keep going, x sub 6, x sub 7, and so on. So, and each one is assigned a probability. So the probability 1 would be for x sub 1. This would be for x sub 2, the probabilities, and so on, okay? So, and they must satisfy these requirements. Each probability, and that says P sub I, just every probability is between 0 and 1. It can't be greater than 1, can't be less than 0. Okay, and all those probabilities must add up to 1. Okay, that's the only requirements of these. So let's try one of these. Okay, this one's a real simple one, you guys. Mr. Bullock gives 15%. Whoops, I put up too many A's in there. Each on A's and D's, 30% on B's and C's, and 10% on F's. You'll find out later this makes a perfect bell-shaped curve. That's later. Um, the students' grades are on a 4-point grading scale, where a 4 is an A, a B is a 3, and so on. You guys are all aware of those, okay? And then so here's the distribution of X. Remember, X is all the grades right here, okay? So the grade is going to be 0, 1, 2, 3, 4. And the probabilities are right below that. That's given up in the word problem right up there. Okay? And then choosing a student at random, what's the probability that the student gets a B or higher? Okay, so it's going to be this probability plus this probability. Now you don't have to do all of this. You'll see the reason I'm doing this in the next problem here shortly. Okay? So you get 45% is the probability. Okay? All right, and obviously that guy teaches too easy. Actually, you guys are doing great, so I'm just kidding. You guys are doing great. Probability histograms, and so this is on page 393, and I'm just going to go quickly on this. You can use histograms to display the probability distributions as well as distributions of data. So here's some probability histograms of the random digits 0 through or 1 through 9. All of them have 1/9 of a chance, which is 0.11111. They're all equally. And this is the one on Benford's law. Do you remember Benford's law of the first digit? The first digit, 1, was most likely to occur. So that's Benford's law. But these are the probability histograms. And a histogram are bar graphs all squished together. We know how to create histograms. And that's actually this lesson right here, you guys. Okay? So that's all that says right there. So here's section D. So show the probability distribution of a random variable x that counts the number of heads in 4 tosses of a coin. Okay, since each flip is independent and the probability is flipping the heads, then your probability is going to be 1/2 on flipping the heads on each toss. And so flipping a coin 4 times gives you 4 times 2, and it's 2 because it's the number of sides. There's 2 sides, and they're flipping it 4 times. So we have 16 different equally likely outcomes. Okay, and then so here is a list of the possible outcomes, and I'm going to let down below let x equal the number of heads. Okay. So here's where we have 0 heads, and you saw this earlier. We went through this before. 0 heads, and then here's where we can do 1 head right here. There's 4 different ways to get 1 heads. Okay, so this says it's hard to see, you guys. Tails, 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 heads, tails, tails, heads, tails. So I'm just floating that heads through there. Okay, x equals 2 you can get 6 of them where x equals 2 when you're tossing a coin 4 times. Here's x equals 3 and x equals 4. Okay, so what's going to ask you next is find the probability of each value of x in section D. Okay, there's 16 total, so only way you can get 0 heads when it's all tails, so 1/16 is 0.625. There were 4 ways to get one head, so 4 out of 16. There's 2 ways to get there's 6 ways to get 2 heads, so that came out to 0.375, and then 4 ways to get 3 heads and 1 way to get 4 heads. Okay, and then it's going to ask you to make a probability histogram of the number of heads. So what I'm going to do is I'm going to have going across the bottom 0, 1, 2, 3, 4 for the number of heads. And going up for the bars for the histogram is going to go up for this one. It's going to go up 0.625. This is going to go up 0.25. This is going to be my tallest bar, 0.375, and so on. So here it is right here. I did it all at once right there. Okay, there's my probability histogram. You probably want to pause so you can write that down. That's the probability histogram. Go ahead and pause. Okay, and when you come back, so is this graph exactly symmetrical? Yes, it is. Okay, if each of you did this event and we collectively put our information together, so if you tossed a coin 4 times, all of you guys in the classroom, would it be exactly symmetrical? Probably not. Probably not. Okay, so find the probability of tossing at least 2 heads. Okay, there's a few ways to toss at least 2 heads, and those are the probabilities when you can toss at least 2 heads. Okay, we can toss 2 heads, or 3 heads, or all 4 heads right there. Okay, and it comes out to a little almost 69%. Okay, all right, now I'm done with the lesson, but one of your questions is going to ask you guys to simulate rolling a die 100 times in your graphing calculator. Here's how you do this, you guys. I think it's your first one on your homework. You go to math and then scroll over to probability and then go look for random integer, and for me it's on number 5 on my calculator, but my calculators might be different than yours, so but it's in math and probability. Okay, then you're going to press in 1 because you're going to roll it once. Actually, going to roll it 100 times, you guys. And this number 6 right here is because it has 6 sides to it. Okay, then you're going to be asked to, whoops, there's no space there. You're going to be asked to sort these next. So how you sort them is you go to list, and then which is on second function stats. It's right above your stats button, so that's why it's second functions. You scroll over to ops, then you scroll to sort A. Okay, go down to sort A. I think it's number 1 on mine. And then you're going to put in list 1 because you're going to sort list 1 and then enter. Okay, and then they'll all be sorted in your list, and then you just go like your old school stuff, go to stat and edit. All right, and then I'm going to go ahead and show you the homework with this. There's your homework, 7.1 to 7.5 on page 395 and 396.